Hello and welcome to Lecture 7 of Critical Thinking. Today we'll be discussing arguments. First, of course, as usual, we'll be meditating a bit, then we'll define arguments, show you some types of arguments, and we'll define a few very important terms for thinking about arguments. Then, of course, I'm going to give you some puzzles, because, this is that kind of class. Alright, so go meditate, come back. Assuming you've done that, let's talk about arguments. An argument's just a set of sentences arranged in a specific way. That's it. There's only one conclusion. That's it. Every other sentence we'll call a premise, and these are often introduced to support the conclusion. For example, if John goes to the store, then John buys milk. John goes to the store, hence, John buys milk. Question: is this an argument? Yeah. Literally just said it's an arrangement of sentences. As you can see here, this is an arrangement, and there's a conclusion. That hence, the word hence, sometimes it's therefore, sometimes it's as a consequence. This introduces the conclusion. So line 3 there, that's the conclusion. Line 1, line 2, they are introduced putatively to support that conclusion. What about this one? If John goes to the store and John buys milk, John buys milk, hence, John goes to the store. Do you think this is an argument? Yes, absolutely. It's just an arrangement of sentences, and it has a conclusion. Now, this is not a good argument. If you think about it for a second, I'll give you a moment. Think about whether you would consider this a good argument, just intuitively. When you've done that, think about this. John goes to the store, hence, John buys milk. Is that a good argument? It's an argument, though, right? It is an argument. Maybe not a good one, but it nevertheless is an argument. Again, just an arrangement of sentences with a conclusion. That's all an argument is. Okay, now, there are different types of arguments. Syllogistic arguments. The word syllogism was used in the Middle Ages to describe a type of logic Aristotle used or invented. You've seen it. It's sort of codified in the square of opposition. Syllogisms have this sort of form. There are 3 sentences. One of them's a conclusion, and they have expressions that use all, some, or none, just like on the square. So this, as you can probably expect, is an example of a syllogistic argument. All S is P, all P is R, hence all S is R. Think about this for a second. Now, just like in the previous lecture, I asked you to draw some diagrams to illustrate. Draw the first statement, right? Like draw one circle in another, one subset, S, in a larger set, P. Do the same for line 2, P included in R, right? And then if you combine those two together, you can think about whether that statement following hence also somehow magically, logically, appears in the diagrams you combine. Now, you could do the same for this syllogistic argument. Again, fits that pattern. It's got some, it's got all, it's got the S's and the R's and the P's, etc. Same tactic. You can visualize with that, drawing diagrams overlapping in this case. Now, that so far should just be a refresher, because I asked you to do it in the previous lecture, and in class we did it for quite a bit. You may have been wondering why what we were up to. Well, it's just this. Identifying types of arguments that are good just based on their form. So we call arguments that are, roughly speaking, good based on their form valid. An argument is valid just in case if all the premises are true, then the conclusion must be true. Okay, and if you're thinking about the diagrams in the syllogistic argument, what we're doing when we draw like all S is P is we're drawing a situation in which that relationship holds, right? That's the subset. That's the one circle in another circle diagram. If we then go on to draw like a subset of P being in a larger set R, if you put those two together, you have one small circle S in a larger circle P, all in a larger circle R. And so you know that the smaller circle S is itself in the larger circle R. And so you know that when you're drawing those first two statements, you have to draw all S's are, right? Exactly. So that is to say, if the first two statements are true, i.e. if you can draw those two diagrams, and you do draw those two diagrams, let's squish them together, if it's the case that when you do that, the third diagram is also drawn, or that third statement is also represented in your diagram, that is just to say that the conclusion is true as well. And talking about truth here is just sort of shorthand. Now, note this does not mean all the premises are true. This definition applies by considering only if, or just the cases if the premises were true. Now, sometimes premises are not true. You can make up all sorts of arguments, genuine arguments, but valid arguments too that have false premises. Again, if the premises are true, then the conclusion must be true. That's the condition for validity, not that the premises are true. Check this out. All S is P, all P is R, hence all S is R. Now, if you're following along with what I said a moment ago, I ask you if this is a good argument, it should be obvious, right? This is valid. Valid is going to be one of the ways in which an argument is good. This is just that chain of diagrams, right? You've got S included in a larger P, P including in a larger R, and when you draw those two together, you ultimately end up drawing S is R as well. How about this one? Some S is P, some S is R. So draw those two. What do we have? Well, you got S and P overlapping. Then you have S and R overlapping. Note how weak that is. You put those two premises together with respect to your diagrams that you've drawn. You could have just three circles, like a chain, right? The S will overlap both P and R, but P and R don't have to overlap at all in your diagram. Most importantly, for our purposes here, it doesn't follow that all P are R, because you can draw at least one diagram in which that's not true, but the first two lines are, right? And remember the definition of validity. If the premises are true, then the conclusion must be true, has to be true. So, putting this another way, if you can draw the first two lines with your diagrams and put those together, and you can draw a situation in which the third line is not true, that argument is not going to be valid. Now, on the other hand, if you draw the first two, put those diagrams together, and then doing so ultimately ends up with you drawing the third line, that's going to be a valid argument. I guess putting this a third and final way, a valid argument is one in which if you draw the first two lines, you're done. You don't have to draw anything else. You don't even have to think about drawing anything else. You get the last one for free. Now this, of course, is an invalid argument. Why? Because you can draw the first two lines and not draw the third one. Just think about a chain where P and R, those bubbles do not overlap at all. Okay, this is what I was saying. An argument that is not valid, we'll call that invalid. To test for invalidity, just imagine a scenario in which the premises are true, but the conclusion is false, right? For example, some pears are delicious, some pears are round. It doesn't mean that all delicious things are round. All right. Now, of course, you may be interested in arguments that have true premises. It's an argument of sound, just in case it is valid and the premises are true. This is the sort of argument that philosophers and most of the public are interested in. People aren't, for instance, too concerned with just purely valid arguments. I'll give you a good example of why. Here's a valid argument. God exists. That's the first premise. The conclusion is God exists. So think about the definition. An argument is valid just in case. In this case, the premise is true, then the conclusion is also true. Well, the premise and the conclusion are the same, so surely if the first one's true, then the other one is true as well. Now, that makes this a valid argument. Think about it, though. Is this a sound argument? Well, I mean, that's what theologians debate, right? We're not going to get there just with validity. Now, I want to show you some of the relationships among the definitions. We ran through this pretty quickly. I don't want you to get overwhelmed, and I think it'll be useful if you look at this picture, you keep this in mind. In fact, I wish all logic textbooks did this. Students have a difficult time frequently thinking about validity and soundness, but I swear, if books just had this diagram in place, the confusion would dissipate. So I'll give you a leg up here. Just keep this diagram in mind, this set of diagrams, and you won't be confused, okay? Look, this is the set of all arguments. There we are. There they are. Just sentences arranged in a certain way and having a conclusion. That's it. They're all in this space. Now, right here, a subset, we're going to have valid arguments. Why is this a subset like this? Well, look, not all arguments are valid. Some arguments are such that the premises, if they're true, the conclusion nevertheless doesn't have to be. And so those arguments are not going to be valid. Nevertheless, there's a subset of all arguments that are valid. That's what we have represented here. Now, a subset of those arguments are sound. It's a subset of valid arguments, right? Because remember, a sound argument is a valid argument, so it's already in this circle with true premises. So you're probably ahead of me here. Which arguments are valid? I'm sorry. Which arguments are valid but not sound? Well, just the arguments such that if their premises were true, their conclusions would be true, but for which the premises are not true and never are true, or something like that. Like those arguments would be in that middle ground. They're not sound, but they are valid. So keep this in mind. This is just reading off the diagram. There are sound valid arguments right there. There are unsound valid arguments right there. There are no sound invalid arguments, right? Okay, moving on. Now, I'd like for you to, on your own, fill in the blanks. I want you here to construct a valid argument. Remember what that means. If you draw the first two, you have to draw the third. All right, pause the video, check it out. Pro tip, of course, visualize. Assuming you have done that, here's the other. Try this. Again, find a valid argument. And now you only have one space here to fill in. Just make those first two true. That is to say, draw a diagram reflecting both of those. And keep in mind, remember, I'm not trying to trick you here, but just keep in mind, if there's any way for you to draw the first and the second lines together and draw a scenario in which the third line is not represented, well, then that's not a valid argument, okay? Because that would be a case in which the first two lines are true and the third one's false, okay? But here I'm asking you to draw a valid argument. So that's a tough condition to meet, okay? There are no counterexamples to a valid argument. That is to say, there are no sets of diagrams in which you draw the first two and you don't draw the third, okay? And that's part of what I mean when I say you get the conclusion for free in a valid argument. If you draw the first two lines, you just end up drawing a third, okay? There's no way you wouldn't. All right. Visualize as usual, and counterexample hunting, which has sort of been a theme underwriting this discussion. I've mentioned it a couple of times, so this won't be new, but I want to call it out by name because it's really a tough skill to develop and it'll require your attention. So counterexample hunting is trying and to basically break putatively valid arguments. So somebody gives you an argument, says this is valid or this is a good argument. You go around and you look for scenarios in which the first two lines are true, but the last one's false. So this is a good way to practice. Take any of those invalid arguments and generate as many distinct scenarios or diagrams in which you draw the first two lines, but you don't end up drawing the third, okay? Which this just tracks on to whatever written here. That will be you generating as many distinct scenarios as you can in which the premises are true and the conclusion is false. Now, again, this takes time, this takes skill. We'll be using this going forward in several other contexts. It's a good idea to get started on a training now. All right, that's it. Talk to you soon.